Hi, welcome to another trigonometry video. We're going to finish off trigonometry by looking at this idea of similar triangles, and we have two little videos to show you what we mean. Right, triangles which have all three angles the same are called similar triangles. So here's an example of two triangles which are similar. They both have the same angles, a 90 degree, a 37 and a 53. One is larger than the other, but they are similar. Here's another example of two similar triangles, the same angles, one is just larger than the other. Here's another one, in fact this is an equilateral triangle, one is just an enlargement of the other. These are similar triangles and they are sort of reflected or mirror images of each other, but they still have the same angles, one is slightly bigger than the other. Even though they've been reflected, they are similar triangles. These are also similar triangles, and hopefully you can figure out that it's just one has been rotated around. And finally, these two are similar triangles. This triangle has a 90, a 63 and a 27 degree angle in it, and the larger triangle also has a 90, 63 and a 27 in it, so they're similar. Alright, let's get into a couple of examples. Triangle ABC, which is the large triangle, and triangle DEF, which is the smaller one, are similar. So what are the missing angles? Well, because they're similar, they're going to have exactly the same angles. So let's start off with this angle of 40 degrees. Up here, I've tried to demonstrate how we're going to take the small triangle and rotate it around until it's the same orientation as the large, and hopefully you can figure out that therefore this angle up here must be 40 degrees as well. If they're similar triangles, they have the same angle, so there must be a 40 degree in that large triangle. Now this angle here is 50 degrees, and because they're similar, that leaves this angle here at 50 degrees too. Alright, example 2. Here are four triangles, ABC, DEF, GHI, and JKNL. And two of them are similar, and in fact they're pairs. There's two pairs of similar triangles. So which triangles are similar? Well, have a look around and spot what you can see. If you can see the angles inside are equal, they are similar. So hopefully after a little bit of observation, you've worked out that these two are similar because they've both got an angle of 90, 32 and 58. And also these two are similar because they've got angles of 56, 90 and 34 degrees. Alright, our third example and our last example. Triangle ABC and triangle CDE are similar triangles. So we're going to calculate what are the missing angles. Well, triangle ABC is this large triangle. And triangle CDE is the smaller triangle, but they are similar, so they must have the same angles. So we know straight away that this angle here of CDE is 106 degrees because it's on the same line as this line from C to B, and therefore it must be the same as 106 below. We also know that angle CED is 30 degrees because it's on this line and must be the same angle as the 30 degrees below. So we've worked out two of the missing angles. Our job is to work out the last angle right up in the top corner, which is angle DCE, and it is angle of 44 degrees. How did I know that? Because I just remembered the idea that angles in a triangle add up to 180. So the 30 degrees plus the 106 plus the 44 has to add up to 180. That's how I worked out that last angle. Awesome. Hey, thanks very much for watching.